Why are polynomial roots so important? Imagine trying to solve a mystery without knowing the clues. In algebra, the clues are the roots of a polynomial. These roots are the values that make the polynomial equal to 0. They are like the secret keys that unlock the puzzle. When you find these roots, you discover where the graph of the polynomial crosses the x-axis. This crossing point tells you a lot about the shape and behavior of the graph. Knowing the roots helps you solve polynomial equations more easily. If you have a polynomial equation, finding its roots is like finding the answers to a puzzle. For example, in a quadratic polynomial, which is a degree to polynomial, the roots tell you exactly where the graph touches or crosses the x-axis. This makes it easier to understand the entire graph and solve related problems. Roots are also directly connected to factoring polynomials. When you know a root, you can write the polynomial as a product of simpler factors. For instance, if a root is 5, then the polynomial has a factor of x minus 5. This process makes complicated polynomials much easier to work with because you can break them down into smaller, manageable parts. Factoring is a key step in solving many algebra problems. The shape of the graph depends on the roots too. If a root has an odd multiplicity, the graph crosses the x-axis at that point. If it has an even multiplicity, the graph just touches the x-axis and bounces back. This helps us predict how the graph will look without plotting every point. It also shows where the polynomial reaches its highest or lowest points, called turning points. Roots are useful beyond just algebra. Engineers, scientists, and computer programmers use roots to model real-world situations. For example, in physics, roots can show where forces balance out or where signals become zero. In engineering, roots help find points of equilibrium or stability. Understanding roots makes algebra less confusing. It connects the abstract idea of a polynomial to concrete solutions and visual graphs. Learning about roots also prepares you for more advanced topics like polynomial division or the Fundamental Theorem of Algebra. This theorem states that every polynomial of degree n has exactly n roots, counting repeated roots and complex roots. In short, roots are important because they give solutions to equations, help us factor polynomials, reveal the graph's shape, and connect algebra to real-world applications. They are the foundation for understanding how polynomials behave and how to solve many types of problems in algebra and beyond.